In this problem, I want to determine if there is a correlation between commute time and well-being. So in order to determine if there's a correlation between two sets of data, there's a few different ways we can approach this, and one is with a hypothesis test. So you don't necessarily have to do a hypothesis test, but that is one option. So let's take a look at, first of all, we're going to put our data into the calculator. So I'll put whatever the x values are into list 1, the y values into list 2. If there's not an indication of which one is x and which one is y, whichever one is first, you'll just assume that that's the x value and the second variable is the y value. So now that I've got that data into the calculator, I can take a look at a graph. So I'll press second and y equals on my graphing calculator to get to this screen. And I turn my plot on. I need to choose the scatter plot, which is the first plot, and that's whether you have this particular model of the calculator or the one that has the different types in 2 rows. Either way, it's the first one. That's the scatter plot. It should say X list is L1, Y list is L2. If they don't say that, then you can change that by pressing second and the number 1 for L1, second and the number 2 to get L2 there. And the mark can be whatever you like, and if you have an option for color, you can make it whatever color you like. So at this point, I'm going to press zoom at the top of the calculator and number 9, which is zoom stat. And I just go ahead and press the number 9. It's a lot quicker than having to scroll all the way down there. So once you do that, then your graph will appear, and here's the scatter plot for this data. So the question is, do we have a line that runs through the data that is not that far from the data? So is this a perfect line? No, but is it pretty close to a perfect line? And this is very close to a perfect line of data, especially considering that real life data never lies in a nice perfect line like you see in an algebra class. So at this point, would I be comfortable in saying that there's a linear correlation between commute time and well-being? I would. So just by looking at the graph here, you can tell in this case there is a strong relationship there. So I would say correlation, yes, and I could be done. But sometimes it's not that clear whether there's a strong relationship, yes or no. So should you need to verify this and you want it to be less ambiguous, this is what we can do. Okay, so what I'll do is I'll go to my test screen, and I get there by pressing stat and the left arrow to go to tests. And I'm going to choose letter F. At least it's F on my calculator, and that's the LinReg t-test. Now, if you don't have this chi-square goodness of fit test, you may not have that, then it will be letter E on your calculator. So either way, it doesn't matter. We're not ever using that chi-square test, so we don't care whether you have it or not. So you either choose E or F, but you're choosing LinReg t-test. And then we get to this screen. So your X list is going to be L1, your Y list is L2, just as when we were doing the graph of the scatter plot. The frequency should be 1, and this is always going to be a two-tail test. So when we do this hypothesis test, the null hypothesis is that rho, which is the population correlation coefficient, that rho is equal to 0. And the alternate hypothesis is that rho is not equal to 0. We really don't just want to determine, is there a correlation, yes or no? So if we do not reject the null hypothesis is saying that there's no relationship. So if we don't reject the null hypothesis, then we're saying there's no relationship. If we do reject the null hypothesis, that means we believe that the alternate hypothesis is true, and then we think that there is a linear relationship. So that's what we're testing. So we're always going to do a two-tailed test here because I don't care whether it's positive or negative. I just care that it's not equal to 0. Certainly you can do a left tail or a right tail test. Is physically possible, but we're just doing a two-tailed test. And then you hit calculate, and let's take a look at the results. So the results of the linear regression t-test, we've got our test statistic and our p-value. So we had alpha was 0.05, and you can see our p-value is small. It says 1.009 whatever e negative 4, which means that our p-value is 0.0001. And that's certainly less than alpha equals 0.05. So based off of that, I can reject the null hypothesis. And then do I think that there's a linear relationship? I'm going to say yes, there's a linear relationship, which is what we thought when we saw the scatter plot. So it certainly shouldn't change. And this is really definite. It's a very small p-value compared to alpha. So we feel very strongly about that linear relationship. Now, how else can you determine if there's a linear relationship? Well, if you scroll down, still on this LinReg t-test, scroll down a little bit more, and you'll see the correlation coefficient and the coefficient of determination. So correlation coefficient is R, and you can see that's a negative 0.9805, so that's very close to negative 1. So based off of that, I would say there's a linear relationship. And then I can also look at the coefficient of determination, the R squared, and that also tells me linear relationship, because this is saying that 96% of the well-being score is coming from the commute time. So it seems like there's a very strong relationship between commute time and well-being, according to this survey. So that's how you would solve that problem in basically 3 different ways. So you can use any of those ways in order to determine if there is a correlation.